Last video we started looking at arithmetic sequences and the recursive formula, which relies on calculating the previous term to get the next term in the arithmetic sequence. We also have what's called the explicit formula. And that's going to be the main focus of today. So let's suppose my parents bought their car back in 1996. They were advised to have an oil change after driving 1,000 miles and then every 3,000 miles thereafter. Thus, the following sequence gives the mileage when oil changes are required. So they needed an oil change after 1,000 miles and then every 3,000 miles thereafter. Now, I know this is an arithmetic sequence because if I take any term and subtract the previous term, so 4,000 minus 1,000, I'd get 3,000. So any term, if I add 3,000, that's how I get the next term. So because I have this constant difference, where if I subtract consecutive terms, I get the same amount, this is an arithmetic sequence. So let's start by writing the recursive formula for the sequence. So if you want to pause the video, let's see what you remember. So here's the recursive formula for the arithmetic sequence. I need the starting amount, so the first oil change happens after 1,000 miles. And then if I want to know when to calculate any future oil change, I would need to take the previous plus 3,000, and that's how I know when it's the next time to take the car in. Now, there may be some limitations to the recursive formula, as you maybe realized as you were doing your homework from last lesson. So let's suppose that my parents, they stick to this 3,000 a mile. Every 3,000 miles they get their oil change, and they know it's due for the 45th oil change, but they lost a little sticker on their windshield that tells them when to go in. Do I want to use this recursive formula to find the 45th oil change and say, 1,000 plus 3,000 plus 3,000 plus 3,000 plus 3,000 plus 3,000? It's probably not the most efficient way to calculate when the 45th oil change needs to happen. So that brings us to the explicit formula. The explicit formula allows us to directly calculate any term. And I'll call that just in general the nth term. Meaning, if I want to find the 45th term, I don't have to rely on the 44th term or the previous term like I do in the recursive formula. So now the question is, well, what is the explicit formula? What does that look like for an arithmetic sequence? Well, let's look at this table. So on the left, I have the number of the term. So the first term, or the first oil change, A sub 1, or the value of the first term, would be 1,000. So the value of the first term in the sequence is 1,000, meaning the first oil change has to occur after 1,000 miles. When would the second oil change occur? Well, that was 4,000 miles. So essentially, I'm taking 1,000 and I'm adding 3,000. And that should occur at 4,000 miles. So this is A sub 2, or the second term in my sequence. So first term, second term. And then we can keep filling out this table. And now I've generated the first 5 terms in the sequence. And notice that instead of saying, plus 3,000 plus 3,000, I just had 2 times 3,000. If I want to add another 3,000 and another 3,000, I could just say 3 times 3,000, 4 times 3,000. Really, to get the second term, I've added on 3,000 once. And to get the first term, I've added on 3,000 0 times. So maybe you can see a pattern developing here. If I want to get the nth term, well, I need that starting amount. And then how many times am I adding on this 3,000? Well, to get the fifth term is 4 terms after the first one. So I'm adding on 3,000 4 times. The fourth term is 3 terms after the first one, so I'm adding on 3,000 3 times. So if I want to get the nth term is actually n minus 1 terms after the first term. So that's how many times I'd be adding on the 3,000. And this leads us to the arithmetic formula, or excuse me, the explicit formula for arithmetic sequences. Now, I still kind of need to know the same information for the explicit formula as I did for the recursive. I need where I'm starting, and then I need to know that constant difference. Keep in mind what this is saying. If I want to find the 100th term, I would start at 1,000. And if I want to find the 100th term, I take 1,000 plus 99 times 3,000, because the 100th term is 99 terms after the first term. So in general, using that table that we just developed, if I want to find the nth term of any arithmetic sequence, I can take the first term and add on that constant difference n minus 1 times, because the nth term is n minus 1 terms after the first term. So this is the first term, and D represents that constant difference. Now, if I look at a graph of this oil change situation, the x-axis I've labeled n, so that's the number of oil changes, and then the y-axis is the a sub n, or the value of the term in the sequence, and that would be the miles. So at the first oil change, that occurs at 1,000 miles, the second oil change is at 4,000, the third oil change is at 7,000, the fourth is at 10,000. And if you notice here, you should see a linear relationship. Now, this is a discrete graph, meaning I just have these points. It's not continuous. I really shouldn't connect them. There's no, I'm not getting like a 1.2 oil change, so I probably shouldn't connect these. But if I did, you should see that line. So if I connect these points and I look at the line, what's the slope of the line? Well, rise over run, it looks like I'm rising 3,000 for every oil change. So the slope is actually 3,000 miles per oil change, and that's your constant rate of change. Remember, slope is the rate of change. So big idea here, because with arithmetic sequences, you have that constant rate of change. You're adding that same constant difference on each time. I should be able to write the explicit formula for an arithmetic sequence, not only like this is one way, but I could also write it in the form y equals mx plus b, because of the linear relationship. And y would be the value of the term, so the value of the nth term would be, m is that constant difference, that rate of change, so I'm adding on 3,000, n is what's on the x-axis. And then if I want to know the y-intercept, this is the tricky part. Well, that's when n is 0. Well, there's really no like a sub 0 term. But if there were an a sub 0 term, a sub 1's 1,000. If I go back 3,000, the a sub 0 term, if we could call it that, would be negative 2,000. So these are kind of the two ways. This is the first one. This is the second one, using y equals mx plus b to approach writing the explicit formula for an arithmetic sequence. So in general, here they are. This is the first way we talked about writing the explicit formula. This is the second one. Doesn't really matter. Either one should give you the same result. So let's look at actually calculating what the mileage would be at the 45th oil change using both of these formulas. So pick one, either the first or the second, whichever one makes more sense to you, and see if you can calculate when the 45th oil change would occur. So pause the video at this point. So perhaps you thought of it as to find when I should get the 45th oil change. I would need to take the first oil change mileage plus the 45th oil change is actually 44 oil changes after the first. So I'd be adding on 3,044 times, since the 45th oil change is 44 times after the first. And if you take 1,000 plus 3,000 times 44, you would get 133,000 miles is when the 45th oil change should occur. If you like thinking of it as that y equals mx plus b, then maybe you went with the second equation. So to find the 45th oil change, your rate of change or your slope is 3,000. I'd be multiplying that times 45, and then the y-intercept, or that b value of y equals mx plus b, would be the 0 term. So if I think of my terms, this is a sub 1, I need to go back 3,000, and that would give you the a sub 0 term, if you would, and that'd be the number you'd be adding onto the n. So negative 2,000, this should give you the same answer. So whichever explicit formula makes more sense to you, these are really both saying the same thing. So I'd like you to try a few examples. Let's do this one, given this sequence right here. Write a recursive formula, write an explicit formula using whichever method you want to, and then find the value of the 200th term. Pause the video now. Here's the first part, the recursive formula. Make sure to tell me where you're starting at a sub 1, the first term, and then to get that constant difference, if you take any term minus the previous, you'd get negative 2.5, which is the constant difference. And just check to see that that's happening every time. Yep, looks like I'm subtracting 2.5, so this is an arithmetic sequence. For the explicit formula, maybe you started here, so this is my starting amount. I'm subtracting 2.5 n minus 1 times. You know, if you distributed this out, you would get kind of the other form, that y equals mx plus b form that I talked about. So if you distribute this, this would be another answer, negative 2.5. That's like your slope, your rate of change. And then if you add these terms, you'd get like the a sub 0 term, where if I went back 2.5, that a sub 0 term would be negative 1.5. That'd be like the y-intercept of y equals mx plus b. So either this or this would be perfectly acceptable for the explicit formula. Now last part, do I want to use the recursive or the explicit formula to find a sub 200? Well, I don't know about you, but I don't want to start here and subtract negative 2.5 199 times by hand. So instead I could just plug in 200 here for n, or to the second equation, either one, doesn't really matter. I'll plug into the first, so I'm starting with negative 4, and I'm subtracting that 2.5 199 times, or n minus 1 times. So in the end, a sub 200 should equal negative 501.5. Next example, suppose my sequence is explicitly defined by this equation. And again, this is explicit because I can plug in any term in the sequence and get out the value of that term. I don't have to rely on calculating the previous term first. Let's see if you can come up with the recursive definition for this sequence. And just a note here, I'd be thinking this is going to be an arithmetic sequence because it follows that y equals mx plus b look. So pause the video and give this a try. Now, I don't know where you started with this, but here's just a look at calculating the first 3 terms of this sequence. I just plugged in 1 for n. So to find the nth term, you'd take 9 times 1 minus 7. Or to find the first term, excuse me, that would give you 2. To find the second term, 9 times 2 minus 7. To find the third term, 9 times 3 minus 7. Here are the first 3 terms of the sequence. You can see that if I take any term minus the previous term, 11 minus 2 or 20 minus 11, I'm getting out 9. That's your constant difference. So if you're writing the recursive formula, you need to know what the first term is, 9 times 1 minus 2. And then to get to the nth term, I'm taking the previous term and I'm adding on 9 for any term after the first. If you use this linear relationship, this is your slope, your constant difference is 9, and this would be like the a sub 0 term, so the first term, negative 7 plus 9, would be 2. Last example, suppose I say there's an arithmetic sequence and I give you the third term of the sequence and the seventh, and I ask you to come up with the explicit formula. I want you to give this a try and think. You really need to know what the constant difference is. So what am I adding each time to get to the next term? And then you also need to know where you're starting. So think about how you would calculate those two things. Pause the video at this time. Now hopefully you started by trying to find the constant difference. There's a couple different ways you could do this. You could think, well, I'm adding on some same amount, which we'll call D, every time, and I'd be adding that on 4 times to get from the third term to the seventh. So if I start at that third term, 11.1, I'd be adding on that constant difference 4 times to get to 23.9. If you solve this equation, you should get the constant difference, which comes out to be 3.2. Another way you could get this constant difference is you could think of this as like slope. So if you think of each of these points as n, a sub n, so the nth term, the third term is 11.1, and the seventh term is 23.9. To find that constant difference, that would be like the slope between these 2 points, or the rate of change. So you could have used the slope equation, y minus y over x minus x, and come up with that same amount. So kind of 2 different, but similar approaches to finding the constant difference. Once you have that constant difference, you would need the first term. So if I take 11.1 and I subtract 3.2, so if I go backwards and subtract 3.2 again, that first term should be 4.7. So now you have all the information you need to write your explicit formula. To get the nth term, I'm taking the first term and I'm adding on that constant difference n minus 1 times. If you distributed this out, you'd get an equation in that y equals mx plus b form, where this is your slope, your constant difference, and that would be like the a sub 0 term. So either of these would work for your explicit formula.